I'll introduce myself. I'm John Heintz. I run the SE team over here at Selector. So I'm going to kind of show a demo with some of the stuff you saw on the screen, but you kind of see how a user will interact with the product. And we kind of pick some scenarios based on real customer experiences. So we didn't do this live this time. We're going to do the recording, but I'll kind of narrate and kind of tell you what's going on here. So I'll start the play button. There was a question about AI ops at the beginning, right? This will go away.
Can you drag it? You can drag it out of there.
There we go. To me, this is AI ops in some ways, right? I don't have an up-down ticket. I have a smart ticket. I have a ticket summarizing an event. So this summarization can be done using our LM, for example. I get a bunch of context like what's affected. And like Sachin was showing, I have a recommended remediation. I have event summary, so I can actually see all the details that are part of this event. And I can now have context to go and take an action. I'm going to pause the video real quick here. So I also have things like preview, mute, acknowledge, incident. So again, when we talk to our customers, they have different workflows they want. Not everybody wants the same thing. Some love teams, some hate teams, and so on. So we've kind of built, like, we can make these buttons do different things depending on the customer. This could create an incident in service now. This could create an acknowledgement saying, John Heintz has this ticket, Bob, stand down. And so it just kind of creates a nice collaboration way to kind of do this. Now, I'm showing Slack because that's the easiest one to kind of demo. This works across all, well, not all, but most collaboration tools that we've had to integrate with. So now, as a user, when I get this, in this case, it's the event that Sachin described earlier, I have basically a decision to make. I can choose to go and start asking questions via the chat apps, or I can actually pivot into the Selector UI and start to do an investigation there. And so in the first demo, we're going to go to the UI to start the investigation, then we'll go into chat apps. In the second one, we're going to do the opposite. We're going to go into chat apps first and then go into the UI. So let's let this catch up here a little bit. All right, so what I did here is I clicked on the alert. It's going to go to the portal. And the first thing I want to point out is everything you see here is relevant to the alert that was just presented. This is not their homepage. This is not any kind of dashboard. It's basically contextual-driven alert view. And so as you saw, we took screenshots from this that we put in the slides, but basically we can do topology renderings, not just physical topology. It could be like cloud-based topologies, routing protocol-based topologies, lots of ways to render this stuff visually. You'll also notice we do a lot of color coding. So we think of things as, is it good or bad? Yeah, that's green and red, but we also have oranges and shades of orange or yellow, depending on how you look at it. The goal here is to say, like, in the case of Verizon, it's not down, it's degraded. So it's easy if it's down because I can just say the circuit's out. In this case, we have to make a call. Are we going to adjust this thing over at AT&T or not? And so we use color coding a lot in our examples. The other thing I'll point out is we think of these honeycombs, and you'll see these different kind of renderings as KPIs. AT&T, is it healthy at this site? Yes or no, green or red. But things make up that health: circuit errors, stability, BGP flaps, et cetera. And so we take that context into saying a thing is good or bad. So I'll keep playing the video. Over here on the circuit SLA, this is interesting too. We do this for a number of customers where they have multiple providers they use, and they want to know what's my worst and best one. Are they meeting their contractual obligations? And so we, again, can take a composite metrics to say, is this SLA, what is the value of it? Am I in compliance with the provider, what they've told me I'm paying for? That can be done with anything. It could be your cloud infrastructure. It could be your instances. It could be your connectivity on your direct connects or private links going to Amazon. Like, if it can be measured, it can be quantified into an SLA or to a health value. But what we've kind of found is that everybody might have a different thing they care about. At my organization, I care about X and Y. Deborah cares about something else. And so our solutions team build this for customers based on their requirements. Now you see here, I clicked on AT&T, and I get what I call a drill down. And I'll pause here again. Basically, it says is I can take like that AT&T, I said it was a rendering of the health of a circuit, but there's lots of details behind it to say if it's good or bad. And so in our software, we call these query chains or drill downs, but basically it allows me to get more context about what is good or bad about a thing and bring up more detail. So in this case, I'm looking at the admin status of the interface. You'll see the operator status below. errors, and so on. If there was a topology there, we would see that.
Yeah,
too.
there's a question.
I have a question about the dashboard that's being shown.
Yeah, please.
Typically, you would have to build a dashboard.
Yes.
And so that would require someone knowing ahead of time, these are the core metrics that I'm interested in if I click in on AT&T.
Yeah.
Is this dashboard being dynamically created, or is it something that it's drawing on a template? Like what's the process?
Two answers. This dashboard right here, if you go back to, I'm at the 313 mark. If you go back to this ticket or incident, behind this, there's a bunch of JSON detail of like device name, timestamp, data, the database that we use for generate the data, and so on. So we reference those details when we produce this visualization. So this is a dynamic dashboard built on the events that happen. Now, in the case of me clicking on AT&T, which I did, and you saw that I got this little drill down here. This was defined by us. We said, hey, if we click on a circuit, what are the things we care about from a circuit KPI level? I click on a device, I want to look at things like the system uptime, maybe the neighbors, inventory of all the different hardware components, et cetera. So we control that in a schema, basically. Customers can influence that dramatically. They may say, I want these 10 widgets in the dashboard, and we build those 10 widgets. The trick, though, is when you have a problem, I don't have to go pull 5 different widgets together to go investigate it. Selector should be smart enough where all that data is presented to me up front, which is how we do it for customers. Answer it okay? Maybe, maybe not. So in short, we have dashboards in the product that everybody gets, and they can be customized. But what happens when you click on something can be tailored to you, if you want it to be. I want these 10 things. In the event that an alert happens, those dashboards are based on the events in the alert. And so that's kind of dynamically rendered on the fly.
Okay, and that alert data is in that JSON blob you're talking about.
And I think you have an example of that in the slides, kind of how that works. Yeah.
Okay.
And if you did want to create your additional, common dashboards, is it something can you chat to generate that? So you have to know GraphQL? Because Lord knows I've had to try to explain GraphQL to a lot of people that use SQL. And it's an adventure.
Yeah, the whole point of chat ops is to not have to have any kind of SQL language.
Yeah.
So behind every widget here is a query, right? It's show me this data as a honeycomb or as a table or as a line plot. But we realize that people don't want to know. They just want to say, I want to see Verizon for the last 12 hours in a certain site.
Yeah. Quick question.
Sure.
On dashboarding. Sorry, Eric. GraphQL got me thinking. How many customers do you see that are going like with Grafana and tapping into this, using Grafana as an example, to tap into this to get visualization more holistically? Does that make sense?
So the question is, are our customers tapping into Selector with Grafana as a visual representation?
Yeah, it's a visualization layer that they can get.
Not too many.
No, I think not many. Because in case of issue with the Grafana is that now you have to pre-build all those dashboards. And in one of our customers, very initially we had worked with them. For every device, they would build the dashboard, they would create the folder, and finally when something happens, they have to now search for that dashboard in which folder it is. So it's very cumbersome. Now with this, when you can get the dashboards and widgets on the fly for the place where the issue is happening, that's like 2 clicks away rather than searching for the dashboard in Grafana.
I'm just thinking like those integrations, like more further. Eric, go ahead.
How do you handle performance and that real-time nature? Because you have a timescale database as well as a hierarchical representation with a lot of potential edges and nodes.
Yeah.
Like the DVR stuff is. I know this because I worked with Sev1, and we had to build a really gnarly system. We learned the hard way that out of the box, like just timescale DB and a lot of those InfluxDB couldn't handle, and rendering was really brutal. So I know it's tough when you're dealing with real time.
So I'll cover this in the deep dive session, but at the top level, this platform is built on Kubernetes, and so inherently like scale out model, right? Additionally, right, even when they talk about data, the various microservices essentially take a snapshot of data and talk over a Kafka bus, right? So using those type of scale out techniques, we handle the performance, right? And again, if you say, if your network grows, this is where you can just add additional nodes and like scale out even the Kubernetes infrastructure.
And are using like sampling rather than full retention? Because that's always the challenge too, is the amount of data you have to hold on to and how long you hold on to it for.
Right now, there is no sampling here. This is actual full data. But obviously, right, in many cases, we don't need to necessarily understand the data in the raw format. We draw insights from it, and then you can work on those insights. So there is a little bit of filtering happens as we even understand and process data.
So I can, there are two answers to that. Yes, for example, the Prometheus says our time series data logs, we keep it, depending on the customer, they want to keep it 7 days, 30 days. That's the raw data we keep. But the sampling piece of it, if we want to keep the data for 1 year, all the events that has happened in the last 1 year, what are the anomalies happened? Those are sampled, those are kept separately because then you can go back. But definitely when an issue is happening, what we have seen, 7 days to 30 days is good enough to go back. We don't have to store all for a year.
Like high granularity, high cardinality is
Correct.
brutal. But if you, like as long as you know min-max average and the major, ranges you need over time, you can go back and.
Yeah, as we, some of the use cases around predictive analytics, which you need longer, and so then you probably start to do average by 1 hour, then you might go to 1 day because you're looking at 6 months of data to say what will happen 2 months from now. So I would try to get through most of the demo here. I'm going to fast forward some of this stuff because it's a little bit repetitive, but the point here is, I'm starting to ask questions, and this is, I think, the lady's question about how fast it. Like I'm saying, what is the circuit SLA for San Diego? And so /select is our way to engage our agent. It's going to hit the UI, it's going to run that query in Selector, and it comes back with an image, which I can then blow up, and I have links, and it's going to summarize it. So like when it says Verizon SLA is 85.23, like that's some of the generative AI comes in. It's taken the data that's in this widget, and it's summarized that in English language. And we'll talk more about that later on, about how that kind of works. But that's kind of how we do it. It's a combination of visual and text renderings based on the question that's been asked. And so the other thing I want to point out, this is kind of it's a demo for this conference, but we actually have customers that have built, and MLB was a great example of this. They took our platform, they built a whole ChatOps interface in front of it, so they can disable interfaces, they can reboot phones, all using a combination of Selector plus Netbox in their case. And so you can actually drive automations from Slack through our platform to things like iTential or other like cloud native kind of automation, Terraform, to go and make differences, to make changes. And so obviously there's more to that and how that works and the plumbing involved, but we're seeing more and more interest in that of taking repetitive common things and saying, let's find a way to automate this via tooling. Now, this is the second scenario where you have, we're saying we have latency detected in a certain area. We have a ServiceNow incident. We have a likely root cause, which is the high CPU utilization on instance UWS 3, and we have a recommended remediation. So now in this case, when I kind of was thinking about building the demo, I go, well, I'm at dinner right now, and so I can't just click on the link because it's Valentine's Day and it's been a busy week. So I'm going to start to qualify this alert a little bit. So I'm going to say things like, show me the topologist application. Because maybe it's a ChatOps application. I don't know topology. Maybe it changed yesterday because it's cloud native, right? And so as I ask these questions, you'll start to get these answers coming back via our Copilot, that here's the topology. Now, we're using a combination of like lat-long information, metadata from the cloud instances like tags, to render this topology. Like how are things connected? Where are they physically sitting at? Like what data center are they at as well as like even like icons to help you understand like what's GCP versus AWS. So the goal here is I have my topology. I have this link in red, which kind of makes sense. But I want to see the actual latency for everything for ChatOps right now because this is a multi-cloud application. And so I'll pause this real quick. And you can see here I have 2 areas that are in red. The rest are pretty low millisecond latency. And so I've kind of confirmed my fear that, all right, this is just between these 2 regions. I don't know my cause yet, just based on the ChatOps interaction. But I've instanted other parts of my cloud network. And so in this case, the user wants to ask a couple more questions like, maybe I'll get lucky, right? Was there any config events? And config changes in like user-led or like machine-led changes are a big, awesome source of data for us. Like If Deb logged in and just did a thing 10 minutes ago and it broke something, I want to know about that as quick as I can because he's not going to tell me. He's going to go hide. But the point is like, this has become a key solution for us is pulling in config events because that kind of tells you the secret of maybe what happened that you wouldn't normally known about. In this case, we're saying that there was an instance type change where it went from a 64 core to a 32 core. In this case, we're pulling it from CloudWatch. Now, alternatively, I can do all this through our portal, which you're going to see now. So that was kind of like me asking questions while at dinner. This is basically showing me a similar dashboard you saw before, but all contextualized based on this chat ops kind of thing. And so now I can interact with the dashboards. I can see the link. I can see why the link's red, the latency display. I have the devices that had the violations that we saw in the latency widget there. That's why those two are there. I have my server health looking at different utilizations for disk, CPU, and memory that we're monitoring, and so on and so forth. And this will kind of go through each of these things. The one I'm going to call attention to here in just a second is the correlation graph. And again, Sachin's I'm trying to give him some time, so I'm not going to go through it in too much detail, but here we actually have, this is cool. We can actually show diffs. People love diffs when looking at running configs and stuff. So we can show diffs, we can show raw configs. Those are all native capabilities of the platform that we can do. And these are more cloud native things. I think there was a question about the cloud side. Now, how are we connecting all this together? This is important. And so you see 4 different events: app timeout, config, high CPU, high latency. Then you have these lines connecting them in some kind of pyramid, right? But when I start to hover over an event, you'll see context. I'm going to pause this. And what we're saying is this event came from CloudWatch. It has an application associated with a tag. We're taking CloudWatch, or taking tag information from Amazon in this case. We have a data center where it's involved, and we have a device name or instance name, a local IP address, and a region. Now, that's for the config event. Now, we also have an app timeout event, for example, and I'll fast forward here a little bit. Oops. These other events have similar context. So this is the one for high CPU or high latency. We look at the metadata associated with these events, look at time, we look at topology. And that's how we start to build a correlation graph of how things are related. Then we use our causal model to say, all right, did high CPU cause high latency, or did high latency cause high CPU, right? And high CPU generally causes latency issues, not vice versa. And that's how we get that causation snippet you saw in the alert. But the key is getting all this data aggregated together, finding events like config, finding anomalies like high latency, getting the metadata associated with that so we can actually get a real smart integrated alert that goes to a platform of your choice. The last thing I'll show is it's a new feature we added the other day, actually not too long ago. It's a DVR. So actually what I did is I took that event and I'm playing it back over time and saying, all right, the event happened at, say, 1800, and you'll see the difference between UTC time and local time here, but what actually happened 2 hours ago? So I can, in Selector, say, show me the last 4 hours of this page so I can kind of see how something played out. So you'll see the config event happening earlier, like right now, and then it kind of, everything's still green though, right? My memory, my disk CPU are green, my link is green up here, but as I go to the next spot, it's still green again, which we see happen sometimes. It may take a minute for a thing to actually take the effect that you didn't expect it to happen. But now, as I progress in time again, you see that now I have this violation happening where the link has gone red, my CPU has gone hot. Very useful for seeing how things propagate across the network, but it's just a native capability of the platform that we wanted to show today because it's neat.
So this is is this an agent installed on each system? Is this a service in the AWS and Azure marketplace that you're installing to scan your entire cloud environment?
It's, yeah, I get what you're going to.
No, so as I was covering at that time, so it can be installed on customer on-prem, or it could be in a public cloud or in our cloud. So we install where the data is available. So it is closer to the data, ingest into the platform and provides this analysis. So now in some cases, we have a remote agent which we install. For example, if you want to do a SNMP walk and collect the data, if you want to ingest data from where the log data is available, the remote agent will get the data and send it to the Selector Analytics platform. So the control plane of where all the analysis is done, that can be in the public cloud or on-prem, where the collection of data can be anywhere else. You as a customer own that. So you say, hey, I'm going to give you a
a role that can read my CloudWatch logs, that's one way of doing it. Or you may say, it's in Kafka already, just hook to this topic and get the data there. Or you may say, I don't have a, you tell me how you want to get it, right? And we'll go work with you to find a solution. The key is if it's Stackdriver logging or CloudWatch or like, NSG logs and Azure, like the data's out there. It's a challenge of getting it all pulled together, which is what we're really good at doing. Like that is our superpower.
So I know so there were two pieces that y'all were referring to earlier, either pulling data from existing tools, which is what you just described, and then having Selector AI as just the monitoring and observability tool, which is what you just described around you have remote agents or you have stuff installed in the cloud or whatever. Okay, so these are two separate things. These are two separate choices that customers have.
No, it can be separate choice or a combination. So, for example, if I look at the Selector, the stack, so the data that is connected, it's as John was saying, it could be through a Kafka bus, it could be a REST API, or through a webhook, or we have remote SNMP engine or syslog engine where it is collecting the data. All is streaming into the platform. So it can be a combination, or it is all available on-prem where the data is next to it. We can get the data from Splunk or any other log store. That's also possible. So what I mean by that is that it could be all at one place, or it could be remote engines and Selector outside.
Got it. So let's say I don't have any monitoring and observability tools right now. I'm not using CloudWatch. I'm not using Azure Monitor, nothing. And I have a bunch of Kubernetes clusters running. I can go and I can install the agent that's running in a pod to collect the data, send the data. Got it. Okay.
Yep. Yeah, we can hook into your Kubernetes orchestrator and start to pull that stuff back, pod status, et cetera.
I have one final question about the demo before we leave. As you were walking through the data, when we look at the real-time data capture, are you utilizing AI in that, or is that data analytics? And are you going to clarify where AI is?
Clarify it.
Okay.
We'll clarify it.
Perfect. Thank you.
Just one quick question about the ITSM side that's previous to the demo. When you create a ticket, when you make changes and you interact with the system, does that continue to add context to the existing ticket so you can keep adding knowledge to that?
Yep.
Yeah, so we have customers where we update tickets, they update tickets, we pull those updates back to us, or we keep updating or can close them out even. It's, again, each customer is kind of different in how they want their ITSM to work. So our job is to be flexible and kind of follow the guidelines they give us. But typically, updates is a huge value add.
There's a lot of systems they have, like if it's 5 minutes later, like it just treats it as a new ticket.
Yeah, then you get flooded.
So yeah, nice, thanks.
Okay. So again, right?
I've got one more question, and then I promise I won't ask any more.
Sure.
You mentioned SNMP let's just talk network devices. I assume, but we haven't seen it. Does it also support like netconf, GNMI?
Yes.
All those things, because
Yes.
I know you know where I'm going with this. Like going into a customer, like, don't talk to me about syslog and pulling SNMP data because that's old school way of doing things and it doesn't scale. So